Hello everyone. In this video, we will learn how to do normalization in Boyce-Codd normal form, or in short, we call it as BCNF form. So Boyce-Codd normal form or BCNF form, a relation is said to be in this form when it has to satisfy, if it is satisfying certain conditions. So if you have a functional dependency of the form like this, alpha is determining beta, or alpha, by knowing the value of alpha, if you can determine beta, so that means beta is depending on alpha. So if this functional dependency is trivial means beta is a subset of alpha. The right hand side is the dependent. So if this beta is a subset of alpha, then you can say the functional dependency is trivial. Another, that is one condition. Second condition is this alpha should be a super key of the relation. So if alpha is the super key of this relation, and if this functional dependency is trivial, then you can say that it is in Boyce-Codd normal form. So basically this Boyce-Codd normal form is an extension of third normal form, but it is on strict terms. That is, as you know, that in the functional dependency, the left hand side, that is, if you have a functional dependency like this, y is depending on x, or x determines y, then you can say x is on the left hand side. So this x should be a super key and y should be a subset of this one. So if BC, the table should be in tree NF. So every functional dependency, as I said, the left hand side of the functional dependency should be a super key. Let us consider this example here. In this one, you, for the first relation, you have student detail. The first attribute is student ID, then student name and zip. The second relation, you have zip codes, zip and city. So in the first relation, student ID is the super key, and in the second relation, zip is the super key. So you can see that this all non-key attributes are completely depending upon this super key, and here also it is depending on the super key. So hence this one is in BCNF form. So we will just see an example, and I'll explain how we can decompose a relation into BCNF. So let us see, consider this example. So we have three attributes: student, teacher and subject. So the functional dependency associated with this relation is given like this: a student and teacher determine subject. That means subject you can determine by knowing the student and teacher. So this is a combination, and teacher is depending upon a student and subject is a combination. Then subject you can determine by teacher. So these are the functional dependencies given here. So when you see the closure of the student teacher, the first functional dependency, if you say, if you take student teacher closure, if you take, you will be getting it as student teacher, and then the closure subject also will be there in that set. So we can see that student teacher and subject, it is this functional dependency is determining all the attributes present in the relation. So this is a super key, means student and teacher is a super key. Another functional dependency closure, if you take student subject closure, if I take, I'll be getting the first element as student and subject, then the teacher also will get added into it. So student, subject, teacher, so all the attributes we are getting from the this functional dependencies. That means that student and subject is a super key. So when you take this teacher teacher closure, if you take, you are getting teacher and subject only as the elements in that one set. So that means this is not a teacher is not a super key. So out of this functional dependency, we can see that student, teacher, student, subject are the super keys of this relation, or you can say the candidate keys of this relation. So here the above, if this relation, if it is to be in third normal form, then the left hand side should be a super key. So every non-trivial functional dependency, this x to y, x must be a super key. So here this is not in BCNF form, because the functional dependency here, the last one, that is teacher is functionally dependent. Teacher determines the subject, or subject is functionally dependent on teacher. So the last functional dependency here, the left hand side is not a super key, whereas the first two one left hand side are super key. So because of this, this relation is not in BCNF form. So we have to actually convert this into BCNF form. And also, if you observe this relation, you can see that this relation has anomalies present because it is not in normalized form. So if we delete this name from the last name from this relation, we lost the information of, suppose I am deleting the student information from this relation, last row. So along with that, the teacher information also gets deleted. So now that one is like even so this is like we have anomalies present in this relation. And another one is like, suppose we want to add a new subject. See, here also updation anomaly is present. So if you are updating a subject here, then we need to update wherever all the tuples where this particular subject is appearing. So the updation anomaly is also present. Even insertion anomaly is also present. If you want to insert a new subject here, unless and until a student opts for that subject, we can add it here. So all these types of anomalies are present in this particular relation. So what we have to do is we have to normalize this relation, and we are going to normalize it in BCNF form. So how we will be doing it? So out of this three functional dependency, the last one you can see that on left hand side, that is not the super key. So what we have to do is teacher subject, this one violates the BCNF. So because teacher is not a candidate key. Now what we can do is we can divide this relation into two relations. So based on how we can divide or decompose the relation into two, that is, if you know, if x to y, that is if y is depending on x, if this violates the BCNF, for in our example teacher to subject or subject, this functional dependency violates the BCNF rule. So here what we can do is, if there is a relation functional dependency x to y which violates BCNF, then we can divide the relation into two, R into two relations, R1 and R2, where R1 is formed by this x and y, the combination of x and y, whatever is on left hand side and whatever is on right hand side, we'll be making R1 x comma y. And R2 will be, the second relation will be forming by subtracting whatever is on the right hand side, that is y, from the original relation. So here we have the functional dependency teacher to subject, which is violating the BCNF rule. So what we have to do, the first relation we will be taking the combination of this x and y, x is teacher, y is subject. So first relation you will be having the attributes teacher and subject. The second relation, you will be subtracting the subject from the original relation. So when you are subtracting this subject from that one subject, when you are subtracting from the relation, you are left with the attributes student and teacher. So your second relation will be student and teacher attribute. So you will be getting two relations. One is R1, the second one is R2. R1 is formed by the combination of this x and y, that is teacher and subject. You can see here teacher and subject. And the second one is formed by subtracting the right hand side, that is the subject, from the remaining attributes. So you will be left with the attributes student and teacher. So you got two relations here, R1 and R2. So here in this particular case, we can see both this one, this has the super key, and if you are taking teacher and subject and student and teacher, all the anomalies have been removed from this relations. So here basically when you are decomposing this relation into BCNF, it is not necessary that it always satisfied the dependency preserving property. Here we have removed all the anomalies present, but the dependency may not be preserved. So maybe after the BCNF decomposition, if you feel that the dependency is not preserved, then what we can do is we can decide whether we need to go for BCNF or we can roll back to the 3NF form, because 3NF, this is an extension of 3NF. So the process of rolling back is called denormalization. So this is how we can normalize a relation in BCNF form. And if the dependency is not preserved, then you have to roll back to the 3NF form and follow the 3NF normalization relation. So I hope you understood how to decompose a relation in BCNF form and how we can, and as I already said, it is not necessary that the dependency will be preserved. If it is not preserved, if you feel that after normalization in BCNF form, if the dependency is not preserved, you can denormalize it and roll back to the 3NF form. So thanks for watching. Hope you understood. Thank you all.